Come on. Yeah, hey! Happy Monday, everybody. All right, let's warm up. Remember, it was almost freezing this morning. Very important, then, that we warm up. Remember the 32 P's of freezing weather. We won't mention them again. This is a quiz-like question for, like, tomorrow. Theta is this big angle, and it's in radians because there's no degrable. And remember, then, it's more than one rotation because we're cutting up a pi into 23 pieces. So this is pi 23rds. How many pi 23rds are in one rotation? One rotation is 2 pi, right? 2 pi is one rotation. So all you have to do, remember, is double the denominator. What's 23 times 2? 46. Okay. So let me grab my finger here. You know what? If you ever forget your stylus, it's a good thing you have your finger there, right? Okay, that you can use. Just like if you ever lock your coat hanger in the car, at least you have your keys to get it out, right? Okay. Yeah. So one rotation is equal to 2 pi radians, and in terms of 23, that's 46 pi 23rds. So whenever you have an angle like this, all you have to do is double, as we said the other day, Friday, the denominator, double the denominator. And that tells you how many, then, it takes 46 of those pi 23rds to make it around one time. So the way that we do this is not converting it to degrees. We take the coefficient of pi 23rds, which is 29738, and we divide it by the number of pi 23rds in a single rotation, which is what? 46, okay? So this is always going to be a different number. It's not always 360, so let's do that. 29738, 29738 divided by 46. And we get 646 rotations. That just brings us right back around to 0. We don't care about that. It is nice to know the number of rotations, but in the end, we subtract those because it's a positive number. We subtract it. If it were negative, we'd add 646 back. And this is what we're after. Notice we want it with all the decimals there. And now we just remultiply that. Always remultiply, whether it's degrees or radians, always remultiply by the same number you divided by, which is in this case what? 46, okay? That, 22, if you remember from Friday, is your new coefficient of pi 23rds. So we don't have a symbol for coterminal angles. They're not equal, but that angle 23rds and now 22 pi 23rds, these are coterminal with each other. And so we don't have a symbol. We can't say that they're equal, right? Because they're obviously not equal, right? One of them is 600-something rotations away from the other. So here's a symbol that I came up with, and it hasn't swept the nation yet. That. It's kind of like a theta, right, which is an angle, but you have an equal sign going through it. So they're not equal, but whatever. So feel free then to start using this on tests, quizzes, and if you're ever at a party with friends or at the HEB, just start using it and see if it can take over the world. There needs to be a symbol for coterminal angles, and I would put this one forth as a candidate. So anyway, those two angles are coterminal. So why is that important? Well, we know now where 22 pi 23rds lives. So remember what we did on Friday. Don't call it that. That's annoying. Okay. This, remember, is pi, always pi. And so that is equivalent to, because we're cutting it up in denominator 23rds, that's equivalent to 23 pi 23rds. Yes, yes? Yes, yes. Always. Just you multiply by the same number over the same number. If you want to label all 4 quadrantal angles, half of 23 is 11.5 pi 23rds. So remember, every time you go to another x or y axis, 90 degrees, or pi has radians, you add another 11.5 to the numerator. Now, we don't have to go all the way around because we want to figure out where 22 pi 23rds lives. So that's going to be where? Just short of the x-axis. So if you want, you could draw that angle at the end of that terminal ray, 22 pi 23rds. Bless you. So that's the coterminal angle. But what I asked you was for the reference angle. So remember, the reference angle is always the positive measure of rotation between the terminal ray and the closest x-axis. So let's give it a name, theta subscript COT for coterminal. And now it's real easy, right? You landed at 22 pi 20-thirds. The closest x-axis is at 23 pi 20-thirds. How much more rotation do you have to go to get there? 1 pi 20-thirds. Yeah, exactly. If that had been 19 pi 20-thirds, we would have had to gone 4 pi 20-thirds to get there, so on and so forth. Oh, why did I put coterminal? Yeah, I don't know. Because it's Monday. We've got to have, reference, reference angle. There we go, reference angle. This one would be the coterminal angle up here. My bad. I'm glad y'all know what I intend to say. Okay, great. All right, so the same rule applies as if degrees. If we land in quadrant 2, it's going to be pi minus the angle. Let's go ahead and draw those 4 situations again, but let's do them with radians, okay? Let me copy this. I'll just reuse that. Copy. Okay. So now in radians, if we land in quadrant 1, theta is the same as theta ref, right? Because it's still positive and acute. All right. If we land in quadrant 2, over here, there's theta. Now the reference angle is not 180 minus theta, but what? What is 180 in radians? 180 degrees. Pi. Yeah, it's pi minus theta. Okay, pi. Any version of pi, like 23 pi 20-thirds. All right. No, not that. Sorry. Too big. There we go. All right, so if we land now in quadrant 3, coming around over here, we terminate in quadrant 3. That's theta that gets us there. The reference angle, we've gone past pi now, so it should be theta minus pi. Right? Instead of theta minus 180? Yeah. Okay. And then the last one, page 6 of 6. We're almost done. Just squeeze it in right there. If we go all the way around here and we terminate in quadrant 4, there's theta that gets us over there. Then the reference angle is what? Excellent. Not 360 minus theta, but the equivalent to 360, 2 pi minus theta. Okay? Sure. It's the same diagram we did the other day. The only difference is instead of 180, we're using pi, and instead of 360, we're using 2 pi. Now, it's going to be real easy for you. The picture you're going to always draw, and you're going to always have pi not labeled as pi, but you're going to have it labeled as 23 pi 20-thirds or 15 pi 15ths or something like that. And so it should be obvious to you, okay? I mean, it should be common sense. Practice. Okay. So far, so good? Everyone warm? Not overheating, right? Okay. Let's go ahead and finish the notes. We are on example B. Okay. So much like the warm-up, we have a large angle, but now we're partitioning it into pi 11ths. The only difference with this one is what? It's negative. Okay? So remember, with degrees, there was always that one extra step. When we subtracted out 360, got rid of the whole numbers by adding back full rotations, remultiplied by 360, we ended up with a negative angle. That was between negative 360 and 0. We had to then add one full rotation at the end to get it to be positive. It's the same thing with this. We're going to have to add one full rotation to make it positive. Now, one full rotation is not 360 in radians, but rather 2 pi. So let me just walk you through it. Pi 11ths is our coefficient. How many pi 11ths in one rotation? 22. So don't just forget about the negative, or you're going to forget about the negative, right? That's common sense. So let's flush, okay? And now we'll type in negative 789,637. And we'll divide that by twice the denominator. If you divide it by the denominator, 11, you're going to be getting the number of half rotations, not full rotations, okay? Hit enter, and that's that many. Now, because it's negative, what do? We add back to get rid of the whole number, which whatever it is, 35892, it should be right there in front of you. And now you can see more decimals appearing, which is what we want. We then always multiply by the exact same number we divided by, which in this case was 22. There's your new coefficient. Notice it's still negative. So let's interpret that. We can say that this angle, using the new symbol, this new angle is coterminal with negative 13 pi 11ths, which is fine. You could draw negative 13 pi 11ths. It's just clockwise. But it's not between 0 and 2 pi, remember. So what do I need to do? I need to add a full rotation. So negative 13 pi 11ths plus how many pi 11ths in a full rotation? 22. So there you go. They have common denominators. What's 22 minus 13? 9. So 9 pi 11ths. So if you wanted to, you could avoid that step and just say, okay, that's a negative 13. How many pi 11ths? 22. Just add 22 to that. Boom. And now you have your new coefficient. What the? Whoa. That is weird. It's not struggling with the decimals when it gives us negative 13. It's saying it's negative 13. But now when you add 22, an integer, to another integer, it's freaking out. What I'm guessing is this right here overloaded the calculator. So this answer right here was probably negative 12.999999999, not an 8. And so when it reported it, it rolled over to negative 13. But it was still storing it as negative 12.99999. That's kind of interesting. But anyway, this is your chance to interpret the calculator and be its boss, right? That's trying to tell you it's what? 9, okay? So remember, you're the boss of the calculator. And you get 9 pi 11ths, okay? Now notice I used an equal sign there. Is that okay? Yeah, that's just a problem, right? If I can't just say negative 13 pi 11ths equals 9 pi 11ths because they're not. But I'm saying negative 13 pi 11ths plus this number is 9 pi 11ths. And that's a true statement, okay? And because of that now, I could say negative 13 pi 11ths is coterminal with 9 pi 11ths, okay? And so let's figure out where 9 pi 11ths lives. You could probably, with enough practice, just figure it out, right? Any guesses where 9 pi 11ths lives? Not France, but quadrant 2, right? Because notice this fraction, 9 11ths, that is just smaller than what number? 1, right? That's just smaller than 1. So that's a little bit less than 1 pi. So it's going to live over here. That's 9 pi 11ths. Well, pi then would be how many pi 11ths? Pi would be 11 pi 11ths, right? 11 pi 11ths to get to the x-axis. So now that we know that, let's shade in the reference angle. There it is in pink. The reference angle is what? 2. Good. 2 pi 11ths. We stopped at 9 pi 11ths. We need to get to the x-axis at 11. So again, 11 minus 9. That's what we're doing. 11 pi 11ths minus 9 pi 11ths. But you can do the math in your head. You're just like, oh, from 9 to 11, that's just 2, right? 2 pi 11ths. Okay? So notice it is super duper important to be able to figure out, first of all, the coterminal angle within one positive rotation. Then you can figure out which quadrant that lives in, and then get to the x-axis to get the reference angle, okay? All right, sweet. So we've seen one with pi that was positive. We've seen one with pi now that was negative. Just remember to add one full rotation back to it at the end. And now we're looking at this fellow. So take a minute, 1 minute, and go ahead and do this one. Figure out what the coterminal angle is, and then what the reference angle is. Tick-tock goes the clock. Bless you. That's a minute. You either have inspiration and you know how to do it, or you're still looking at it saying, that's cute. Right? A little intimidating, but still cute. 1499876.3 pi. That's more than one rotation. So remember, if it looks like there is no denominator, because that's what we've been doing, just put it over 1. Right? And now you're counting by pi once. Huh. How many pi once are in a full rotation? 2. Yeah. 2 pi once, also known as 2 pi. So go to your calculator, take that number. Make sure you type it in correctly. 1499987876363 divided by not 1 but 2, and you get that. And now you subtract out 7499381, and no more decimals appear. Oh, that's interesting. So then I remultiply by 2, and I get my new coefficient of pi once. So we come back over here, and we say that this is coterminal with 1 pi once. George, also known as pi. Yeah, that's coterminal with pi. So let's see where pi lives. Dun, dun, dun. Pi lives over here. Boom. Right there. That's pi. So that terminates on the negative x-axis. What's the reference angle? Yeah, it does not exist. Yeah. If you wanted to quantify it, it would be 0 degrees. But 0 degrees is not an acute angle, okay, because it's not an angle, really. An acute angle has to be strictly between 0 and 90. Just for what it's worth, if you have an angle that terminates on the x-axis, or the y-axis, sorry, it could be up here, or I'll just draw it down here. That would be at 3 pi halves. The reference angle is going to be also DNE, and the reason is because it's 90 degrees, okay? So if you have an angle that ever terminates on a quadrantal angle, there is no reference angle, okay? You can just say it doesn't exist. Okay, so this one doesn't have a reference angle, but notice it's coterminal with pi. Now, you could do it like that, or let's glean some generalization from this, right? That's what math is all about. Look for patterns and try and come up with generalizations. This is just an odd multiple of pi. Would you agree? That number, that the coefficient of pi, it's an odd number because it ends with 3. Let's go ahead and start thinking about full multiples of pi. Here's 0. Here's 1 pi. Here is 2 pi. Here is 3 pi. Here is 4 pi. Here is 5 pi. Here is 6 pi. Dang, we need to have a bake sale now. This is 7 pi. This is 8 pi. Dang, we're like the Aggie moms. 9 pi. I think they make cookies, not pies. Okay. Do you notice a pattern emerging? Anyone? What's that? The odds are on the left. All of odd multiples of pi are coterminal with pi, yes? And on the right, we have even multiples of pi, which are all coterminal with bless you, where in this case, bless you is 0. Okay? That's a weird variable to use, right? Bless you. But in this case, bless you equals 0. So if you ever see then just some number times pi, you can immediately discern what it's coterminal with. It's either going to be 0 or pi, depending on that number right there. If that's an odd number, it's coterminal with pi. If it's an even number, it's coterminal with 0. That easy, okay? Sweet pie. Anyone ever had mincemeat pie? There's actually no meat in it. Yeah, anyway. It's like really, really rich, like apple or pears or something. And it's, wow. It's pretty good, though. You're thinking, man, I wonder if there's like a T-bone in here. And it's like, nope. Okay. Is this angle in degrees or radians? It's in radians because there's no degrable. Rads. Okay, cool. What's different about this fella? There's no pi. Well, that's a bummer. Okay. If you don't see a pi visible, that just means that the number already ate the pi. Yeah. The pi is in the number. Okay. It's already in there. So we can't do it by this route. We can't just say, oh, we're counting by pi, blah, 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 right? Can't do it that way. But we can still do the same, essentially, process of dividing out full rotations, okay? We just have to do it a little bit differently. So here's what we're going to do. We're going to take 36142.51, and we are going to divide it by the number of radians in one full rotation, which is what? 2 pi. Now, here's where you got to be very, very careful. Very careful. If you, and let's do this together, I'll be not very careful with you, flush, right? Okay, and then wash your hands. Okay, here we go. 36142.51. If we go divided by 2 pi, 2e, that's not right. Okay. You ever eaten E? No, that's not as delicious as pie. If you do that, is that what we want to do? Is that correct? If you use the diagonal division bar. No, because your calculator is programmed by your dear Aunt Sally. Did you know that? She is a TI calculator programmer, and she has those PEMDAS rules. So it's going to go from left to right. It is going to divide by the 2 and then multiply by the pi. So that's the same as like putting the pi in the numerator. That's no good. Okay? Let's see what that wrong number is. It's like, oh, that's wrong, right? So here's what you do. One of two things. If you are heck bent on using the diagonal, then you either say 36142.51, which I'm going to store that as x because I'm tired of typing that in, okay? You either take that number and you divide it by either parentheses the quantity, 2 pi, okay, in parentheses. So now, PEMDAS, parentheses first, it's going to multiply this and then do the number divided by that. Either do that, or you take that number, what is it, 36142.51, and you divide it by 2, and then you divide it by pi. Okay? Divide by 2, divide by pi, because they're both in the denominator, and you get the same answer. Okay? Or you can use alpha y equals number 1 and the horizontal division bar. And you can say the number, and now you just cursor down, and you can say 2 pi. Okay? And notice now the 2 and the pi are both in the denominator, and you get the same answer. Okay? So that is what? What does that number give us? 5752 is the number of rotations. Good. So we subtract those out. Minus 57, 52, and then boom, you get that. We always, never not always, then remultiply by the exact same number we divided by, which in this case was 2 pi, okay? And now that's okay if you just put 2 pi like that, right? Because we're multiplying. We want to multiply by both of them in the numerator, and that is your new answer because we're dealing with pi, 1.628. So let's go ahead and let's draw that, 1.628. Well, let's write that down first. Theta coterminal is 1.628. And I'm going to go ahead and write rads behind it, just as a reminder to myself. Okay. So now, like we've been doing, we need to determine where that fella lives. Okay? So anyone know? There's no pi visible, so we can't cut up our pies like we've been doing. Remember I told you that it was good to know that pi halves is about 1.57. This is, of course, 0. Pi, as you well know, is 3.14. 3 pi halves, remember, was about what? 4.7-ish? I think it's exactly how I wrote it, 4.7-ish. And then 2 pi is about twice pi, which is 6.28. Okay, so if there's no pi visible, this is kind of good to know. So now you can see, where does 1.628 live? In quadrant 2. It's past 1.57. So we're going a full length of a radius, plus another half of a radius, plus another 1.28 of a radius around any given circle. Okay, and with the terminal ray is here, 1.628. Dot, dot, dot. Okay? Now, for the reference angle, it's not as easy now because we don't just have multiples of pi, integer multiples of pi. But the same process applies. We are stopping just short of the x-axis. So the reference angle should be what? Not 180 minus theta, but pi minus 1.628. Now I'm going to put dot, dot, dot because that means it's a live number. We want to use that number in its full decimal glory. You never, ever, 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 ever want to use a rounded or truncated approximated number for a subsequent calculation. So if you think that you're going to need it again, like you need to do some more calculations and you want to come back to this, store it as, I sorted it one already as x, but you have a whole alphabet here. A, B, C, D, blah, 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 right? I know you still sing the song when you have to alphabetize. I do it too. Hit alpha, and then right below it is A, okay? And there it is. Now, you didn't really need to do that this time because it was the last answer on your calculator, right? So in that case, you could just hit pi minus, and to get the answer, remember that second, and then way down here on the negative, you can recall the answer. Pi minus the answer. And you get, boom, that. Or, since you stored it, you could have also have done pi minus alpha A. Boom, and you got that answer. Now, is that answer acute? Yes, because it's between 0 and 90 degrees, which is pi halves, which is about 1.57. Yeah, that's between 0 and 1.57. So that is an acute angle in radians. So admittingly, it's not as fun when pi is not visible, okay? Because you're not thinking about food, but you can still do the process, okay? So you've seen kind of one example of each type, with a pi, without a pi, a negative, a positive. Just remember, for a negative angle, doesn't matter if pi is visible or not, for a negative angle, your last step before you report the coterminal angle is to add one full rotation to it, okay? That concludes this section, and because we're on assembly sketch today, we have about 5 minutes left. So, yes, are there any questions? Yes. Absolutely, we can work another problem while you go to the bathroom. Yes. Yeah. Y'all want to try another one? Let's try one. Let me give you a negative one here. So we're having a quiz tomorrow, by the way. So